Hi, my name is Brendan Whelan. I'm an exercise and sports science student at the University of Central Queensland in Rockhampton. Today I will be giving a presentation on my findings on the effects of fatigue on offensive versus defensive training periodization in amateur basketball. Basketball is a game that is both aerobically and anaerobically demanding, despite being played at high intensity for short periods of time. Fatigue is the catalyst that can bring down even the best teams to their knees. We can measure fatigue in several different ways. We can measure through heart rate, blood lactate accumulation, and rate of perceived exertion. Studies have been completed in fatigue in basketball, but are more so gender specific, as seen by Scanlon, Descombe and Reburn in 2011 and Scanlon, Descombe, Reburn and Diabo in 2012. Similar with a female specific, Rodriguez, Fernando and Perez looked into position specific instead of playing role, which they measured the center versus guard. Vukovic studied the response on guards and centers in a playing role, showing the main difference was due to tactical demands in their playing position rather than their playing role. This has led me to ask a few questions. Is there a difference between offensive and defensive playing roles when it comes to fatigue? And if so, what impact will there be? Will they be able to shoot better if they're less fatigued? Will they be able to defend better if they're fatigued? All these questions need to be answered. We had 14 mixed gender amateur basketball players volunteer for this study. All participants were requested to complete and sign an informed consent and sign it, detailing all procedures. A full set of demographic and anthropometry information was collected prior to the testings. The results can be seen on the slide. How we did the testing? Well, we monitored all 14 players during a game simulation. The game simulation we decided upon was 4 versus 4, playing on a half court. There was no fouls or free throws or jump balls in the simulation. An adequate dynamic warm-up consisting of light jogging and dynamic stretching was completed prior to commencement of testing. Prior to the match data being collected, participants completed a line drill test, which is a sport-specific repeat test of 143 meters in distance. This test involves participants sprinting from the baseline of each of the near free throw line, halfway line, far free throw line, and far baseline and back to the baseline, each time in a sequential fashion. This procedure was also replicated post-match, so we could calculate the percentage of fatigue using the recorded total time to complete the test. During the game and during the line drill testing, heart rate was collected by a Polar Team 2 system onto a personal laptop. Then at the 5-minute mark, we collected blood for testing and analysing blood lactate accumulation from the earlobe, and also we got each player to register their score on the Borg RPE scale. All this testing was done once per condition per person, which meant each person recorded details for offense and another person calculated details for defense. there was 20 minutes recovery before changing rules, so to get a proper reading. The equipment used was a Polar Team 2 system. Each player was required to wear a polar heart rate monitor. We also used the Fusion Sport Smart Speed gates, and they were used for the line drill test. An AccuTrend Plus was used to analyze each player's blood lactate accumulation. And as stated previously, we used the Borg's 6 to 20 RPE scale. The results, well, they showed a non-significance. As you can see here, there was not any major difference in any of the offense or defensive results. Even in the line drill test, there was no major difference noted. When we took a look at the p-values for each of the ones lactate, RPE, average heart rate, line drill 1 and 2, fatigue percentage and playing time, none of them came near to our significance of 0.05. All the data was put through a paired t-test to identify if there was any significance in the playing rules. The evidence shows that when playing defense, heart rate responses are higher, which is more likely attributed to the playing rule. Montgomery, Pine and Meehan found playing rules yielded a mean heart rate of 152 and 147 respectively, which are lower than what was presented, but was assessed to be no significance. Also, our measurement for blood lactate accumulation showed no significant difference. Fatigue with the line drill was rejected and removed due to the fact that there was only 20 minutes recovery between the two games. Future research directions we would do in future would have a full game simulation, which include using the full court and a 5 versus 5 standard game and using full rules. We'd also increase the sample size so we can get a stronger significance. Another thing to consider would be time analysis. Cross-referencing with heart rate will give us a closer indication of fatigue. In conclusion, there was no significant difference in fatigue in a playing role. Testing can be repeated in the future with the research directions stated previously. The practical implications: similar physiological requirements create similar fatigue responses in the playing role, but other aspects such as skill development for specific roles may be in need of targeting. Thank you for listening. Here is a list of references for your information. Any questions can be sent to brendan.whelan@cqmail.com. Thank you.